Hi, this video is entitled Python Dictionary. We'll look at the dictionary container, the last of the four containers that I highlight in the Session 3 handout. So you can see I actually have 5 items listed. Files are not really a container, but the 4 main containers that we've been looking at are lists, tuples, sets, and dictionaries. Lists, tuples, and sets are different from dictionaries in that they contain individual objects. Lists and tuples contain a sequence, an ordered sequence of objects. Sets contain an unordered sequence of objects. Dictionaries are very different in that they contain a sequence of pairs of objects, and they're unordered like a set. So when we initialize a dictionary, like mydict, we can use the special syntax attendant to dictionaries, which is curly braces, and then pairs of objects that are separated. The pairs are separated by commas, and the elements of each pair are separated by a colon. So you can see we have not 6 objects. Well, we have 6 objects here, but we don't have 6 elements here. We have 3 pairs. The 3 pairs, each of 2 objects. Any object, well, almost any object, many objects can be used for a key, but usually we have a string key. You can think of a dictionary as almost being its own little individual variable set. Because any type of object can go in either bucket, we can, especially if we think of the first bucket, the left side, that is the key, what we call the key. We think the key is always a string. We can think of this mydict as being, as I said, its own little variable set, a variable namespace, where A is equal to 1, B is equal to 2, hello is equal to there. These are our variables within the dictionary. And that's what a dictionary is for. Dictionary is for pairing up objects so that you can do lookups. Other names for a dictionary besides dictionary, which implies that there are words and definitions, which also implies the idea of lookups, are a lookup table, an associative array, because basically, or you could always call it an associative list, because it's sort of like a list that associates one object with another. And it's also sometimes known as a hash in other languages. The idea of a dictionary, of course, is common to many languages, but it has different names. Dictionary, lookup table, associative array, hash. Dictionary and lookup table are probably the ones that are most germane to us right now, because we're going to talk about looking things up in a dictionary. Of course, what we'll also do is talk about how to add to a dictionary, how to look at individual elements of a dictionary, and how to loop through a dictionary. Now, although a dictionary is very different from a list in the sense that it's not just an individual item, many of the same structures, it's not just a list of individual items, but is instead a list of pairs. Many of the same structures and functions that we've come to associate with these containers is still available in a dictionary. For example, we can loop through a dictionary with for. We can check the length of a dictionary with len. We can check for membership in a dictionary with in. These are all available to us. They'll be used slightly differently with a dictionary, but we'll see that in a second. What we want to look at now is how we can add to a dictionary and retrieve elements from a dictionary. We're going to use the same subscript syntax that you're familiar with lists and tuples. For instance, if we wanted to access a value in the dictionary and we knew the key, we could get back the value by simply using a subscript, and instead of putting an index number, an integer in the subscript, we would put the key that we want to look up We get back 1 in this case. The idea of a dictionary is being able to associate some kind of key that we would want to be able to look up some information. We might, for example, want to know the name of a person based on their user ID. And here I'm using the example of NYU IDs. If we were looking through a data source and we wanted to build up some sort of table that allows us to look things up, and we were interested in people's names, and we had access to their user IDs, we could build up a dictionary that would allow us to look things like that up. So for instance, perhaps we know this fellow's user ID, his NYU net ID rather, is DBB212. We don't know what his name is and we want to access it. We'd need only put the key user ID into the dictionary to get back the value. So it's very much like a list. If you compare it to a list, which might contain 3 elements, and we wanted to get, let's say, the second element, we'd say print mylist1. Look at the similarity between them. In a sense, a list is sort of like a dictionary with keys. If we were to express it as a dictionary, it might look like this. It looks a bit like a dictionary, so that if my list was a dictionary and we put an integer in there, it would allow us maybe to look things up. I take it back, of course. I made a mistake. We start with index 0. So you can think of a list almost as if it were a dictionary with integer keys starting at 0 and always consecutive, in a sense. In the same way, you can think of a dictionary as being like a list, except that instead of integer indices, we have these arbitrarily decided upon key indexes. The key would be a string, usually. And in this case, as I said, we're keying NYU user IDs to, let's say, a person's full name. So this is how we can access a value within a dictionary using a key. The idea of a dictionary is, and when you're dealing with data and you want to decide what structure would be best to store my information, you'd use a dictionary if, number one, you knew that the keys are unique. So we'd be talking about a data set in which you knew that the keys that you're dealing with are unique. That allows the lookup. That allows us to say, well, what's the value for this ID? And there's always only going to be one value. Since the keys are unique, of course, that means that we can't, or we could add a new key and value to the dictionary, but it would overwrite the old one. The other is that, like a set, the list order is not guaranteed. We can say that the element order the elements are unordered. So there's no guaranteed order of a dictionary. You never know how a dictionary is going to be organized by Python. It's very much like sets in that regard. The keys are unique. What that means, of course, is that if we were to reassign a key and just change it to George Higginbottom and then print mydict, let's see what we get here. You can see that after we reassigned DBB212, the dictionary now contains the same 3 keys, MM64, DBB212, and JX23. The other 2 pairs have remained unchanged, but because we reassigned DBB212, it now contains the new value. What happened to David Blakey in this case? Well, unfortunately, he disappeared. He was overwritten by the new reassignment. So you can see that dictionaries are unordered. You might also be able to see that the order I'm sorry, not that they're unordered, but that the keys are unique. And you might also be able to see that the order is changed. We put it in as DBB212, MM64, etc. But Python decided to change the order. This helps, again, as I mentioned with sets, this helps Python do sorting, and it also helps Python do lookups. Dictionaries are about looking things up. We build dictionaries so that we can look things up later, usually. In addition to being able to change an element using a subscript, we can add new elements to a dictionary using a subscript. So here, unlike a list, we're able to actually add a new element using a subscript syntax. We can say that in the dictionary, the key OPE23 is associated with the string OP Evans. We've added to the dictionary. If we print this out now, you'll see that it has the additional element. There are now 4 keys in the dictionary. So dictionaries allow us to add elements in this way. Let me ask you something. Do you suppose a dictionary has a method like append? Well, it certainly doesn't have a method called append, because that would, again, as with sets, that would imply that we'd be adding to the end of the dictionary. But there is no real end to the dictionary. The order of elements is entirely up to Python, and it could change with any alteration we make to the dictionary. The order could change. So we don't rely on a dictionary for that. We rely on a dictionary for lookups, and we also rely on a dictionary to maintain the pairs. The pairs will always stay the same. So one thing we might be doing in our program is building up a dictionary and then looping through it to see what's there. We'll be doing that in our homework when I ask you, say, to associate a user ID with a city, or even to count the number of instances of something using a dictionary. It simply maintains the pairs for us, and we can go through them later on. There are many, many applications. If you're new to this and you're wondering sort of where am I going to be using this, there are many applications for dictionaries. It's why they're one of the built-in structures. Dictionary is extremely useful facility, and again, you're going to look at your data set and say, I think a dictionary would be useful here, because the data is paired in some way, and also because you know that the keys are going to be unique. Keep in mind that the keys are unique and that the elements are never ordered in any particular way. So good. So that's initializing the dictionary and accessing an element. And also here we're accessing the element. So we could say David's name equals mydict dbb212. That would give us back my name, the string. We can add a new element. We can also change an existing element. That's something that we showed, and it's the same syntax, obviously. Another way that we can get value out of a dictionary that's a little better, and it's better because dictionary keys, of course, have to exist for you to be able to access them, is something called get. Let's look at a problem that we might run into. Here we're accessing my name using my NYU ID. And here we're accessing someone else's name through their key XX23. The only problem is there is no XX23 key in the dictionary. So what sort of result will we get if we try to access it? We get an error. It looks like there was something called a key error exception. Key error occurs when you try to access a key that doesn't exist, as in the case of XX23. If we had said JX23, we'd have no problem accessing it. We would get Josephine's name. But since we're trying to access a key that doesn't exist, we're running into a problem. Sometimes this can be a real problem because we don't know necessarily whether a key that we've run into is something that's in the dictionary. In that case, we have to use in to find out. So we can say if XS23 in mydict, then do this thing. So now we're putting it behind a gate that makes sure that XX23 is there before it works. And that means that, of course, nothing happens because there is no XX23 in my dict. So it did not go through and try to access XX23. And that works, and it works well. Another way you could work it is you could put it in a try block, as we saw from last time. And then if we're going to try to do it. And then if there's an exception, we could say we could just go ahead and put in an error message of some sort. It tells us that XX23 doesn't exist, and that and then it prints my dict. Notice that the key error block did get executed, and that's because this time we put the access of XX23 into a try block. The key error occurred, and then the key error block was executed. But there's one other way to do this, and it's probably a better way. It's interesting. It's called get, and we don't use an index for it. We simply use a regular argument. It's a method of mydict, and it's called get. And what it does is it checks to see if the key is in the dictionary. If it is, it will assign the value, the associated value, to whatever variable you place to the left of the parentheses. But if the key doesn't exist, we'll have a problem. Well, actually, wait, I didn't save. We won't have a problem. That's the point of get. Do you see the none here? None. Well, as it turns out, get will return a value if the key doesn't exist. What it won't do is throw an error. So we're not going to get a key error exception, thankfully, because key error exceptions kind of suck. And having to check, well, they can be annoying, I should say. And to have to check ahead of time to see if a key is there constantly can be a real pain. Doing any kind of checking ahead of time can be a pain, and it can be a lot of excess verbiage and a lot of excess tests that are sometimes hard to maintain. But with get, if we pass the key that we're looking for to get, mydict get, mydict will return a value even if there's no key, and the value it will return is something called none. Now, we haven't talked about none yet, but none is basically a null value or an empty value. It's a value that means there is no value, and we'll talk about that a little bit later. It's sort of like the undefined value in other languages like Perl. It is possible to put in a default value to say, you know what, if this key is not in the dictionary, and I don't know if it is, if it's not, don't give me none. Instead, give me some other value. In this case, we're asking for 0. So if we run that, you can see 0 is there. I can just maybe take out my dict and run it one more time. 0, we get 0. We get 0 because 0 is the default value and XX23 doesn't exist. We could show it working by putting in a JX23. Now it's JX23, so it should get back a value, and it does. We get back Josephine Xavier. So you can see that get is an excellent way to check for a key and to get back the value of the key and to suggest a default value to Python in case the key is not there. It's a lot easier to work with this than it is with the straight subscript syntax, just because of that key error problem. So we've looked at reassigning, we've looked at accessing a key 2 different ways. We've looked at reassigning a key and a value in the dictionary. We've also looked at creating a new key and value in the dictionary. And that's something that I want to emphasize. Students have tried to make use of another function called, I think it's called extend. Now I keep forgetting. But there's a method of dictionaries that allows you to add to the dictionary. It's called update. And it allows you to add any number of keys and values to a dictionary. In fact, it allows you to concatenate 2 dictionaries so that they so that they're all one big dictionary. The problem with adding a single key and value using update is that it's probably less efficient. It also seems like overkill. Update really is for taking one dictionary and adding it to another. So if your only purpose is to set up a new key and value in the dictionary, it's a bit overkill to create a new one pair dictionary so that you can add it to the old dictionary. That would look something like this, and it's something that I want you to avoid. I'm not putting it here to give you any ideas. You see here I'm passing, well, what is this? Can you see what this is? It begins with curly braces. It has a colon in between two, looks like string objects. This is a one pair dictionary. A one pair dictionary, which we're passing to update. Now, unfortunately, this works. Passing a one pair dictionary to update will update the dictionary with that one pair. But that's not how I want you to do it. I want you to do it like the standard way that most developers take, which is to set the key and the value using a subscript. So instead of that, the thing to do is this. Now I can see that this is a little less intuitive than the update, but I want you not to use update, and you shouldn't. It'll really point you out as a newbie, I think, if you try to use it in a work situation to anyone who knows better. Here we're creating two new keys and values in the dictionary. And this is generally the format that we use to add a key and a value to a dictionary. Of course, normally what you'll be doing, as we're doing in the homework, is looping through a file, pulling out data from each row of the file, and from each row of the file, setting a new key and a value in the dictionary. So, of course, just like any other structure, usually these, it's certainly possible, and usually it will be the case that we pass in variable names, variables that point to other objects rather than actual literal values. So you can see in this case, we're taking my key and my val. This is two strings. These are assigned to labels, and we're using the labels in the dictionary update. I shouldn't say update. We're setting a key and a value in the dictionary. This is true, of course, of anything. Anytime you can see a literal value that goes somewhere, you can put a label that points to that literal value, and that's always the case across the board. So if we clear this and run it again, you can see that we added the XX23 and hello. We added the XX23 and hello, and that was done using this syntax, which is the syntax that you must use. MyDict key equals val. The key and the val could be, any label that points to an object that can be put into a hash like strings. Lastly, we're going to look at looping. Looping is accomplished in the same way. Well, we'll look at looping and then we'll look at in and len. Looping is accomplished in the same way that we loop through anything. Of course, if we had a mylist and we said with mylist A, B, C, D, and we wanted to loop through mylist, we would say for element in mylist, print EL. Well, as it turns out, we can use that exact same syntax with a dictionary. For key in mydict, print key. Now, interestingly enough, we're not going to get everything from the dictionary. Just going to take the list out now. We're not going to get everything from the dictionary when we loop this way. Let's take a look at what we do get. We get back, well, what do we get back? Let's take a look. Oh, we're getting back the keys. Oh, by the way, I should point out, you may notice here I didn't join these together in this way, which would be standard, because Python allows us to line up elements, whether they're list, tuple, etc., in a way that's much more readable. And of course, I'm lining them up this way in order to be readable. But Python allows it because it's sometimes very convenient to add and update variables or values in your code using this lined up syntax. Now let's look at what happens when we say for key in mydict, print key. We're looping through the dictionary in the same way and using the exact same syntax that we would use with a list or a tuple. But in this case, we're using a dictionary, of course, and what we're getting back are the keys. The reason why this is key, the reason why this is useful and meaningful is that if you have the key, you can get the value. So it should be quite easy to get the value now if we have the key. If we know that the key, that is the label here, if we know that the label is being assigned one of the keys at any given moment and that it's going to loop through all the keys, all we need to do then, if we want to access the value associated with that key, is just access it through mydict with a subscript. Add a print statement here for clarity. But if we say print key and then print mydict key, we get back all the data, the key and the value, the key and the value, the key and the value. You can see that once you have the key, you're able to look up the value, which again is why we sometimes call it a lookup table. If you have the key, you can have the value. You can access the value in the dictionary. And we do that constantly. This is one of the ways to loop through and access all the elements in the dictionary. When you're looping through a dictionary, you need to access the key and the value, of course. And the way we do it here in this method, and we're going to look at another method right after this, is by looping through the dictionary keys and then using the key with a subscript syntax to get the value. That's one way to loop through the dictionary. Here's another way that might be slightly more efficient, and I believe it is. It's certainly more efficient in Perl, so I can't imagine that it's not more efficient in Python, largely because it's quite reasonable that it should be. And that is to say for key.val, key comma val, which these can be any labels, in mydict, and we'll say items, print key, print val, and print. So we're going to use the exact same syntax that we did with the other looping method, and we'll get the exact same output. So what's going on here? I don't know if you recognize this from tuples, but this is key comma val. It has no parentheses, but I can tell you right now that it's a tuple, and I hope this syntax works. Items actually returns a list of tuples, and every tuple has two elements that we can then unpack. It's not so important to understand that right at the moment because we'll go over it again a little bit later. But basically what we're getting back from items is two elements, and those two elements are the key and the value from the dictionary. So this should also work in the same way. Yeah, there it is. Now I'm going to add an additional print statement as is my want, just to clarify that we're definitely looking at the latest. It's not just because I didn't save it. So there you see new edit. So we get back the key and the value from the dictionary, and it's perfect. We're getting back all the keys and all the values. And notice here that key is the key and val is the val, and these are variable names that we arbitrarily created. I just wanted to make them clear. But the main thing of interest here, and the main new thing here, is the items method. Items method clearly is loopable. We're saying for key val and mydict items. So items is actually returning some sort of sequence to us and allowing us to look at the key and value. Again, we'll go over why this syntax works and why it's not something more pedestrian-like for key and mydict, which basically clearly lets us loop through one object at a time. This seems to be letting us loop through two objects at a time, and in fact, it sort of is. But we'll go into why a little bit later in the class. I would say that if you wanted to choose and if you wanted to be the most efficient, I would suggest using items. The great thing about items is that we have the key and the val in named variables right away. The other great thing about it is that Python doesn't have to keep looking things up. Here, Python's delivering us a list of keys, and that's great. But then it has to go ahead, and every time it loops through, has to go ahead and look up the key, look up the value using the key in the dictionary. And that sort of lookup takes time. So it seems much more efficient for us to just call items and get back the key and the value every time Python loops through an iteration of that dictionary. So that's looping in Python, looping of dictionaries in Python. Finally, the in and len keyword. Let's print len mydict and see what we get. Print, and why don't I just say length of mydict. Again, I'm going to have to wrap this in a string method so that it's stringified. So then we're going to print a blank line, and then I'm going to say if jx23 in mydict. Now we did this before. We did this before when we were talking about testing for a key, so shouldn't be new. But I did want to re-emphasize it. We're talking about len here, and we're talking about in. So length of mydict is 3, and jx23 exists in mydict. Now look at what's the idea with 3? Why would it be 3? Well, we have 3 pairs. So the length of a dictionary is not the number of individual objects that are contained in it, because you can see there are 6 individual objects in mydict, but rather the number of pairs, which makes the most sense. We're only interested in pairs with dictionaries anyway, so we build them up as pairs, and we're wanting to count them as pairs as well. So it looks like that concludes the video on dictionaries. We'll have one more on files, and that will conclude the videos for this week, week 3. Thanks for watching.